Okay, good morning, everyone. Today we will make use of engineering equation solver, or EES for short, for calculating thermophysical properties for pure substances. So we'll do that for both ideal gases as well as ideal gas such as air, as well as for steam. Okay, so if you want to calculate any property, it's a very intuitive software. You can simply write there's a function called enthalpy for calculating enthalpy. Similarly, entropy for calculating entropy, and so on. So for a start, we'll just go to help, and in the help index, we'll type in enthalpy just to get the exact uh, function, right? So this one gives you an example and also gives you a description of what it is, right? So we'll just copy this, and you can use it to calculate enthalpies for gases, liquids, and solids. But we're just interested in gases and liquids, or essentially fluids. So we'll just copy that, copy the first 4 lines, and paste it here. Okay, so now this one, once you've pasted it, you could simply go into this equation mode, which where it comes out nicely, right? So it's giving us, the first line gives us the enthalpy for air at 25 degrees Celsius. So here only one property is mentioned because, as you remember, for ideal gases, enthalpy only requires temperature, right? If you have temperature, then you can calculate the enthalpy for an ideal gas. You can also calculate the internal energy, right, using just one property, which is temperature, of course. For other substances, such as steam and others, you will need two independent and intensive properties. So here, for steam, if you have provided temperature and pressure, you can calculate the enthalpy. Now, there are cases where temperature and pressure may not be enough. They are dependent on each other, especially when we're talking about saturated states. So you'll have to get one more property in there. But otherwise, as long as it's compressed liquid or superheated vapor, temperature and pressure will do the job. So in the third scenario, if you're dealing with a saturated situation, and the steam that you have is saturated vapor, then you can simply mention, you can get the properties by um, mentioning two independent intensive properties. The two independent intensive properties will be the temperature here in degrees Celsius and the quality. Quality of one tells you that it is saturated vapor. If I give quality of 0, it's going to tell me it's saturated liquid, so on and so forth. Okay, so let's go back to the equation window, which is where we can edit this. So here, this is here I could also, instead of doing it this way, I can define a temperature T1, for example. T1 is equal to 25, right? And I can put that, if I want, I can put the units in square brackets. And then when I go to the, and maybe let's say I define T2 as, I don't know, maybe 100, let's say. And let's say you define pressure P2 as 100 kilopascals. So here I can put the units in square brackets, kilopascal. And let's say the quality, you define it as quality for state 2. Let's say you just define it as 0, right? So you can define all of these before giving the function as well. So when you go to the function, for example, if I want to get enthalpy of air at a temperature T1, where T1 can be anything, it's 25 here, I can simply write it as T is equal to T1, and it'll give me the exact same answer, right? I can, of course, change the temperature there, and I don't have to come back and change everything again on the function itself. Same way I can do it for steam, where I can define the temperature as T2 and the pressure as P2. Okay. 100 kilopascal, by the way, is close to atmospheric pressure. Okay, so that's why I'm giving 100 kilopascal there. Quality, you can define it as X2, right? And again, the temperature here, we can define it as T2. You can come up with another temperature, T3 or whatever as well. It's your choice. Okay, just showing you how it works. So again, look at it in formatted equations. It's nicely laid out. So here you're getting the enthalpy of air at T1, enthalpy of steam at T2, and enthalpy of saturated liquid in this case at X2, where X2 is 0, and at T2, right? So two independent intensive properties. Once you have this, you simply have to click this solve button, and it'll give you the properties. Okay, so the enthalpies are in kilojoule per kilogram, and the temperatures and pressures, of course, in degrees Celsius. Okay, so this one here is the enthalpy of saturated liquid. Now, I will also show you how to get the entropy, right? Entropy is the same way. You can simply write instead of enthalpy, you can write entropy, or you could go to help. And if you're not so sure, just go to help and type entropy. Okay. So here we have examples again, and you can simply copy it, right? So copy this, go back, and you know, paste it here. So now the interesting part is when we talk about entropy, even for ideal gases, we need temperature and pressure. Okay, only temperature is not enough. Temperature is enough as long as you're looking at internal energy and enthalpy. But for entropy, you need temperature and pressure, right? So we have temperature given here. You can replace it with T1, and pressure, we can simply define it. So let's go ahead and define P1. Let's define it as again 100 kilopascal, right? So here I will write P is equal to P1 just to make it atmospheric pressure. And then for steam, of course, you just do the same thing. You can in fact copy paste from it, right? So the only thing that's changing is the function is entropy now instead of enthalpy because we want to get entropy now, right? And so the last one will give you the entropy for saturated liquid. Okay, so here, go ahead. Uh, you can click this. This is an optional step. You can click this just to see everything works out. Everything is as per your wish, and this is exactly what we want to get. And then just click calculate, and you get enthalpies, entropies at the desired state. So that's it. It's as simple as that. You can use this for writing further equations and go on and solve it. The key point here is that on the right hand side you should have a known value, right? You cannot put unknown on the right hand side. That's how it works. It also does some iteration. So it's a very useful tool, very useful software. We'll use more of it when we solve examples in the class.